Alright, today we'll be looking at lipids, the final subtopic under biochemistry. So, lipids are just like carbohydrates, they consist of carbon, hydrogen, and oxygen. However, they have a much higher proportion of hydrogen than carbohydrates do. Another thing about lipids, they do not have dipoles since they are insoluble, which means they don't really have a charge, a net charge on them. Lipids includes fats and oils. Fats are generally solid at room temperature. Oils are generally liquid at room temperature. Now, triglycerides now is a form of lipid. It's a type of lipid that is actually made up of 3 fatty acids and 1 glycerol molecule. So you have 3 fatty acids, 1 glycerol molecule. These two combine to give you a triglyceride. Now we call fatty acids because they have the carboxyl group attached to them. So fatty acids are basically just chains of carbon, hydrogen, right, and oxygen, but because they have a carboxyl group attached to it, we call that a fatty acid chain. Glycerol molecule is let me move to the next one, then you'll see what I'm talking about. Alright, so generally a fatty acid molecule or chain, generally they are chains. So a fatty acid chain would look like this, but this is just a general depiction. You have a longer chain with more carbons and more hydrogen. Alright, and note we have our carboxyl group right there. This is the general structure now of a glycerol molecule made up of 3 carbons, right, and the rest is hydrogen and oxygen. So this is a glycerol and this is a fatty acid chain. Alright, let's move now to the formation of the triglyceride molecule. Alright, for the formation of the triglyceride molecule, notice I have 3 fatty acid chains and 1 glycerol molecule. So some books will refer to it as fatty acid tails and glycerol head, right? So you have the glycerol head right here, and you have 1, 2, 3 fatty acid tails. Now, how we get these molecules, 3 tails and the head, to be joined together? They undergo a reaction, a condensation reaction, just like what we have in the proteins and the carbohydrates. We have a condensation reaction also occurring here. That reaction occurs between the carboxyl group on the fatty acid tail and the hydroxyl group on the glycerol head. So as I said, between the carboxyl group on the fatty acid and the hydroxyl group on the glycerol head, you lose water, and then you're going to form what we call an ester bond. So ester bond is formed when we bond the fatty acid tail and the glycerol head. Good. So this is what the ester bonds would be like. The fatty acid tails would continue all the way out there. We don't have to write that again, but that's the fatty acid tail, the ester bond in the middle right there. Alright, so moving on now, looking at what we mean by hydrophobic. Hydrophobic just refers to water 18, which means that any molecule that is hydrophobic, they will not react with water. Fatty acids can be either saturated or unsaturated. Alright, so if a fatty acid is saturated, then it means that whatever lipid that the fatty acids are joined to make, that lipid also becomes saturated. Now what saturated means is that each of the carbon is linked to its neighboring carbon, and the other 2 bonds are bonds that are formed with hydrogen. That may sound a little bit confusing, so let me clear it up. So in order to clear up what we mean by a saturated fatty acid, is basically a fatty acid where this carbon that is bonded to this carbon, right, there's only a single bond between each of them. So the other two bonds that are free would be with hydrogen. Or another way of looking at it is that all of the free bonds outside here are saturated. They have all hydrogen, and between each carbon there's only a single bond. Good. So by definition, saturated fatty acids mean that all the carbon to carbon bonds are single bonds, and the other free bonds that are left are hydrogen bonds, totally saturated with hydrogen. Alright, so by definition now, unsaturated fatty acid tail would be one where you have a double bond between the two carbons. And that double bond means that you're only going to have a single bond left for a hydrogen with this carbon and a single bond left for a hydrogen in this carbon. Good, so there's a double bond between the carbon, and there can be more than one double bonds, but at least one double bond in the fatty acid chain where between a carbon and a carbon makes it unsaturated. That unsaturated means that you have less hydrogens now than if it was saturated, where the single bond between each carbon would make available the possibility of two hydrogens. Good, so unsaturated means you have a double bond joining the carbon. Now, one of the significance of unsaturated fat is the fact that the fatty acid tail will now have a little bend or a kink in it because of this double bond between these two carbons right here. If we had a saturated fatty acid, then we would have the carbon more in a linear, horizontal, parallel position, they're more fixed and straight. But because of the double bond now in a unsaturated fatty acid, we have a kink in the tail, right? And that kink can be very, very beneficial, and we'll look at that as we continue. Also to note about lipids, example of a lipid here is a triglyceride, is that these are very good energy stores, right? So triglycerides really have at least 2 times the amount of energy. A 1 gram of triglyceride can give you twice the amount of energy that 1 gram of carbohydrate can give you. So therefore, triglycerides are excellent energy stores. They also act as good insulators. So you know that animals that live in very cold environments generally have a large storage of triglycerides. So because it helps to insulate them in the cold environment. All right. So those are some of the things you can note. Remember also that triglycerides, they are stored in the adipose tissue of humans and other animals as well, and they are also important for storing fat soluble vitamins such as vitamin D and vitamin A. Good. All right.